lesson on similarity. Hopefully you've already done the first lesson on similarity, which is like finding a scale factor, and we're going to now use that in some more GCSE style questions. So our objectives today are find missing side lengths in similar shapes, and then find them in more complicated shapes and those with a decimal or fractional scale factor. So that's when we have to be able to do it without a calculator. So let's hopefully we can get on all right. So first thing, I'm just going to start with a basic question. So the question says, the diagram shows two similar rectangles, work out the missing side length x. So because we know it's similar, and it says in the question, the first thing we need to do is find the scale factor, okay? And the only sides we can compare are the 55 and the 5, so we can use that to find that scale factor is 11. And because we know our scale factor is times by 11, to work out x, we're going to look at the corresponding length, so it's going to be 3 times 11, which is 33 centimetres. Nice and easy, very straightforward. That would probably only be 2 marks maximum. This question here, feel free to pause the video if you want to, or you can go through it with me. So we've got two similar triangles, so we know they're similar because they've told us work out the missing side length. So to work out the scale factor here, we're going to use our heights because we've got two heights, they're in the same position. So we're going to do 3.75 divided by 15 to give us a scale factor of 2.5. Now what we need to remember is that is going that way from the small triangle to the big triangle, okay? Now when we're working out the missing length, we're actually going from the big triangle to the small triangle, which means we're actually dividing by 2.5 to go that way. So it's good, I like to draw arrows on the diagram to help me in the exam, but that's up to you. So then I'm going to do 32 divided by 2.5, and that gives me what my side length is, 12.8 centimetres. So there's 6 questions here for you to have a go at. Pause the video, try them, and I'll put the answers up in a moment. So here are your answers. And I've included what the scale factor is, just in case you got that wrong, which meant your answer was wrong, but hopefully you haven't. And there are all your answers. Now here's a little just 2 mark GCSE question I found that I thought you might want to have a go at. So have a try at this, again work out the scale factor first and see if you can work out the missing length AB. And in case you can't quite figure out where that is, it's this pink side here. So pause the video and have a go. So to get 2 marks, you should have worked out the scale factor is 1.5, and then to work out AB, you do 5 times 1.5 to get 7.5. Easy. Okay, so let's make it a bit more tricky. So these questions would be worth more marks because they're slightly different, but we're still looking at similar shapes. So it says work out the length DE. So you might be like, oh, hang on, there aren't 2 shapes here, but we've got to look a little bit deeper into it. So first thing I always do is make sure I know which length on the picture I'm actually working out. So DE is there, and I'm going to call that X, but you can call it what you like. Now, like I said, it hasn't got 2 pictures. So what we're going to do is we are going to split this shape up into 2 triangles. So you can probably see the outside triangle and the little triangle on the top. It's like it's sitting on top of each other. And then so when you've drawn that out, put on your dimensions. So I've got 5 on my small triangle and 6, so that's nice and easy. I've got X at the base of my big triangle, but just be careful here. Think about what the full hypotenuse is on that triangle. It's actually 24 because it's that whole side length. Okay, so when you've got that, now you can do what we've been practicing already, which is work out the scale factor using your division method. So 24 divided by 6, so the scale factor is 4. And then to work out X, we're going to do 5 times 4, and we get 20 centimetres. So I'm just doing what I've done before. The hard bit is getting it into a format that you can understand and apply. So we're going to do another one. Again, this one doesn't look nice. Okay, this is like 2 triangles flipped over each other. So first thing we're going to do is going to label the side that we want. AE is there from A to E. Now I'm going to draw out again, just a little sketch. I've got a big triangle and my little triangle. I've got 8 and 6 on my small triangle, and if I flipped it over, I have 9.6 on the bottom and the X would be on the other side. So think about literally flipping over like a reflection. And again, we can work out a scale factor by looking at our base lengths, so I'm going to do bigger divided by smaller, 9.6 divided by 8. That gives me a scale factor 1.2. And the missing side length is going to be 6 times 1.2 to get 7.2. Because remember, I'm going from smaller to bigger, so I'm timesing it. So have a go at these 3 questions. These are all GCSE style. See if you can work them out and pause the video. So these are your answers for these questions. Now, obviously, again, put the scale factors in so you can see exactly what you needed to get. Now, the final one is just a little pointer on what to. So the final thing I want to go through is what to do if you've got a really weird scale factor, or it's recurring, or we want to try and leave that as a fraction and work with that. Now, there's no questions to practice on this, but I just thought I'd show you anyway. So first things first is we're going to find the scale factor, the only lengths we can use that are in the same position are the 7 and the 3. So to work that scale factor out, we're going to do 7 divided by 3, which is 7 over 3. I'm going to leave it as a fraction. Now I'm just going to type that into my calculator to see what it would be on my calculator, and that would be 2.3 recurring. Okay, we want to keep it accurate, so we're going to keep it as a fraction. So to find y, I've got my 4 and my y, so I'm going to do 4 times 7 over 3. I'm going to keep it accurate, and that gives me 28 over 3. If you're wondering where that came from, you might remember back to multiplying fractions. 4 is the same as 4 over 1, so we're effectively doing 4 times 7 and then 1 times 3. So 4 times 7 is 28, 1 times 3 is 3. And we're going to leave it as an improper fraction, but you could change it if you wanted to. And then to find x, again, we're looking over there, we've got 3.75 times 7 over 3, which isn't very nice to look at. And if you didn't have a calculator, it might be quite tricky. So what I would suggest is if you've got something like this, change the 3.75 into a fraction as well, and then you can multiply the fractions together. So I know 3.75 is 3 3/4. I think most of you should know that. And then I've changed it to an improper fraction by doing 4 times 3, which is 12, add the 3, which is 15 at the top, and then leave the 4 at the bottom. And then when I've got that, I can do the timesing together the fractions, top times top, bottom times bottom, simplify it, and then you end up with 35 over 4, or 8.75 if you want to change it to a decimal, or if you wanted to change it to a mixed number, you could do that as well. So that's what you would do if you had a slightly interesting or tricky scale factor. So hopefully you found this video helpful. Please check out the other video if you haven't checked out already. I'm going to be doing lots more of these, and hopefully you can get a gauge with them, and it'll be useful to go over at any point. So see you next time.